So now we're going to look at the quadratic formula. So if you recall, if you have 3 squared, it's equal to 9. Also, negative 3 squared is equal to 9. 4 squared equals 16. And negative 4 squared equals 16. Thus, the square root of 9, what number squared is 9, is plus or minus 3. So traditionally we haven't been working with positive and negative square roots. We just said the square root's always the positive number. But in actuality, square roots can take the negative number as well. So the square root of 9 is actually plus 3 and minus 3. And the way we write that is this plus minus sign, plus on top, minus on the bottom. So that is how we traditionally write it. And that way there, we know that there are 2 possible answers to the square root of 9. The square root of 3, positive 3 and negative 3. There are 2 possible answers to the square root of 16, positive 4 and negative 4. This is true of any square root that we're working with. We're going to have a positive or negative value. Also, recall that quadratics touch the x-axis in 0, 1, or 2 points. So these are the number of real roots, the real numbers that we can actually express and have an understanding of. There are other types of numbers out there that are not real numbers, complex numbers and such, that we don't work with in our course. But just recognize that when we're working with a quadratic formula, we are going to have either 2 answers, 1 answer, or no real answers. So let's get to the quadratic formula. If you start with the standard form of the equation, y equals ax squared plus bx plus c, and set it to 0, solving for x by completing the square, you get a solution to find the roots of any quadratic equation, whether or not it's factorable. What we're doing here is getting an equation that will give us the roots or zeros, whether or not it is easily factorable by us. So we've done some factoring, and there's been cases where you can't factor the quadratic. This will give us a result whether or not we can factor. This is going to help us out with some cases where there's some difficult decimals or not factorable situations, and we have unreal roots. So here's how it works. For the equation ax squared plus bx plus c, we take the a, b, and c values and we substitute them into this formula, where the zeros are negative b, plus or minus, so there's going to end up being 2 separate equations here. Negative b plus the square root of b squared minus 4ac divided by 2a, and negative b minus the square root of b squared minus 4ac divided by 2a. So this is 2 separate equations, one with a plus, one with a minus. We just write it like this to save us some time in doing the exact same calculations through most of the work. How do we use this? Well, let's take a look here. Here we have y equals 2x squared minus 18x plus 40. So all we need to do, sub these values into our equation. We could try and factor this and find 2 numbers. Are there 2 numbers that multiply to 80 and add to negative 18? Yes, there are. It's going to be 10 and 8. So this is something we can factor. We can factor this. But we're not going to factor this. We're going to use the quadratic equation. Okay. So once we can factor, the quadratic equation will work. X equals negative b. So negative b. B is negative 18. The negative of negative 18 is positive 18. Plus or minus the square root of b, which is negative 18 squared, minus 4 times a, which is 2, times c, which is 40, divided by 2 times a. So we've just filled in the a, b's, and c's with their respective value. Again, be careful with the b value here because it is negative b, so it's the opposite sign. When I now simplify that, I get 18 plus or minus the square root of, and then I do 18 squared minus 4 times 2 times 40, which is 4, divided by 4. The square root of 4 I can do. That's 2 over 4. Now, here's where we got to break it up. We can't do any more calculations because we got to do this here. So we got to break this into two parts. X equals 18 plus 2 over 4, or x equals 18 minus 2 over 4. 18 plus 2 is going to give us 20 divided by 4, x equals 5. Or 18 minus 2 is going to give us 16. 16 divided by 4 is going to give us 4. These are the answers to this equation here. And it gives us the roots. So we can use a quadratic equation to factor if it's factorable. In the next case here, two numbers that add to 10 and multiply to 112 is going to give us a little bit of some issue. So let's try the quadratic equation. X equals negative b, so the negative 10 in this case, plus or minus the square root of 10 squared minus 4 times a times c all over 2 times the a value. Let's do each part. Negative 10 stays the same, square root of. And then I have 10 squared minus 4 times 7 times 16. It's going to give me negative 348 over 2 times 7 is going to give me 14. And actually, I'm going to stop here because if I try and do the square root of 348, I'm going to get an issue. In my calculator, it's showing error, non-real answer. Your calculator may show an error or something like that. We cannot take the square root of a negative number. It is not a real number. So there are no real roots is our answer. That means this graph here does not cross the x-axis. Because we know it's opening up, it's going to look something like this. It's never going to cross the x-axis. So that is a situation that occurs with the quadratic equation. Okay, so you'll either get answers, they could be in fraction form, they could be with decimals. Just depends on the situation and the specific numbers. This one we could actually factor ourselves and get 5 over 4. We'd common factor out the 2 actually first, and then we'd have two numbers multiplying to 9 and adding to 20. 5 and 4 would end up being those numbers, and we'd solve that for them. However, this allows us to check any situation, whether it's factorable or not factorable, or whether it's difficult to factor. Now, flipping that over, let's take a look here. So by consequence of the quadratic formula, if you do a little bit of playing around and with it, what you will find is that the axis of symmetry, the x value of the vertex, is negative b over 2a. So if you're given a quadratic in the standard form, we can answer a few different questions about it with the quadratic formula, with the axis of symmetry. So first off, let's take a look here. We got a path of basketball is modeled by negative 0.25x squared plus 2x plus 1.5. where y is the height in meters and x is the horizontal distance in meters. So we got some sort of basketball getting thrown around, probably looking something like this. Starts here formally and comes down. So we got some sort of graph looking like this, starting at 1.5 meters above the ground. When does the ball hit the ground? So we want to know when the ball hits the ground, so we're looking for a 0. So we can find zeros by factoring, but we got these decimals. Rather than trying to factor with decimals, why don't we use the quadratic equation? So we have x minus negative b, which is negative 2 in this case, plus or minus the square root of 2 squared minus 4 times negative 0.25. That's our a value. And then our c value of 1.5. We're going to divide all that by 2 times the a value. So now if we calculate that in the brackets, we have (5.5). The square root of 5.5 over negative 0.5. So now we can take the square root of 5.5 and we have x equals negative 2 plus or minus approximately 2.35 over negative 0.5. Now let's break this up to find our two zeros. X equals negative 2 plus 2.35 over negative 0.5, or x equals negative 2 minus 2.35 over negative 0.5. So we'll solve both of these. What we're going to get is I did this one first. 8.7 and then negative 0.7. This is the only acceptable answer. This one here would be inadmissible. Why? Because it's this point here. That one there, not going to work for one of our zeros. So our zero, when does the ball hit the ground? The ball hits the ground at 8.7 meters. Now part B says, how far does the ball travel horizontally? Now this becomes useful because we want to know, this could become useful at times if there was 2 points. In this case here, the ball started here at 0 and it traveled all the way over to 8.7. So how far horizontally did it travel? In B, started at 0, landed at 8.7. How far did it travel? It traveled 8.7 meters. That's it, that's all. Why? Because this is 8.7. If it started at 0, that's 8.7 meters total travel time, or travel distance. Lastly, how high does the ball reach at its max? So what is the maximum value here? What is the vertex? We want to find the vertex of this. How do we find the vertex? Well, we know that little bit of information here, that the x value of the vertex is negative b over 2a. So for part C, we're going to take negative 2 over 2 times negative 0.25. And the x value becomes -2 over -0.5. And thus we get 4. So our x value peaks at 4. So that's the x value. How high does the ball reach at 4 meters? Well, we simply plug that into the equation. Y equals -0.25 times 4 squared plus 2 times 4 plus 1.5. And we calculate all that out. And we get, what do we got here? That's 16. And then a quarter of 16 is going to be 4. So -4 plus, that'll be 8 plus 1.5. So we got 4 plus 1.5, 5.5 meters. The ball reaches a max of 5.5 meters. So there we have finding the zeros, finding the distance traveled, finding the maximum height of a ball. Again, quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, and then the vertex is x equals -b over 2a. Do you have to memorize this? It would be nice, but I will allow you the formula on the test.